Good morning, students. Jai Swaminarayan. Welcome to our video lecture of chapter 7. The most interesting one, students, permutation and combination. Chapter 7, students, apply in day-to-day life. One of the most interesting chapters, students, of 11th standard. In that chapter is, students, permutation and combination. Now, students, in the first part of the chapter, we have to study one principle, and that principle is fundamental principle of counting. Fundamental principle of counting. Now, students, let us understand this with the help of an example. In short, I can write this as FEC, Fundamental Principle of Counting. Now, students, say these days you rarely go for party, but say you have to be ready for a party, your friend's birthday party, and for that, say you have 4 t-shirts and say 3 jeans. Isn't it? You teenagers are fond of t-shirts and jeans. So, say you have sorted out 4 t-shirts and 3 jeans, and among these 7 clothes, you have to form a pair. I write the 4 t-shirts as T1, T2, T3, and T4, and 3 jeans I write as J1, J2, and J. Now you can pair your first t-shirt with any of the 3 jeans, either with T1, J1, J2, and J. So one t-shirt can be paired with 3 jeans. Again, T2 can be paired with 3. T3 can be paired with 3 jeans, and T4 also can be paired with, you can say, 3 jeans. So one t-shirt can be selected in 4 ways, and one jeans can be selected in 3 ways. So total number of pairs are 12. 3 pairs with T1, again 3 with T2, 3 with T3, and 3 with T4. Or conversely, one jeans can be paired with 4 t-shirts, again second jeans can be paired with 4, third jeans can be paired with 4. So either or, the pairs are 12. So you can form a pair and get ready for the party in 12 ways. So students, what is the fundamental principle of counting? Suppose one event can be done, or one event can occur in m ways. This I generalize as m ways. After that, the second event can occur in n ways. Suppose the first event or n event can occur in n ways. After that, the second event can occur in n ways. Then the total ways in which both the events can occur in order are n to n. This principle is called, students, fundamental principle of counting. Say, let us generalize. An event of selecting a t-shirt can occur in 4 ways. After that, an event of selecting the jeans can occur in 3 ways. Then the total ways in which both the events can occur in order are 4 into 3, 12. In general, n to n. So if there are 3 events, suppose first event can occur in M ways, second event can occur in N ways, and third event can occur in P ways, then the total ways in which both the events can occur in order are N to N to P. Say you have 4 t-shirts, 3 jeans, and say 3 pairs of shoes. Then you can get ready in 4 into 3 into 3. That is 12 into 3, 36 ways. So fundamental principle of counting is not restricted to 2 events or 3 events or 5 events. This can be generalized for any number of events you want. So for 2 events, this fundamental principle of counting is N into N. For 3 events, the fundamental principle of counting is generalized as N in P. And for 4 events, the fundamental principle of counting is generalized as N in P. Generally, students, you may not have more than 4 or 5 events in your syllabus. So, once again, last time, what is fundamental principle of counting? Suppose an event can occur in M ways. After that, the second event can occur in N ways. Then the total number of ways in which both the events can occur in order are N to N. If it is 3 events, it is N to N into P. If it is 4 events, then students, it is N into N into P into Q. If it is 5 events, then N into N into P into Q into R. You can generalize this for any number of events which occur one after the other in order. Now students, we are doing exercise 7.1. The question reads as that you are given 5 digits 1, 2, 3, 4, 5. Using these 5 digits, you have to form 3 digits number such that the digits are repeated in second, the digits are not repeated. Now this forms an integral part of the question. Students, exercise 7.1, answer 1. You are given 5 digits and these digits are 1, 2, 3, 4 and 5. Using these 5 digits, you are supposed to form 3 digits number, where in the first case digits are repeated in the number, and in second case digits are not repeated in the 3-digit number. So we do the sum in 2 cases. Case 1, repetition of digits allowed. Now this is like puzzle, students. This is like puzzle. So you will enjoy students doing this type of sums. This is like puzzle. It's very interesting. For 3-digit number, I have to draw 3 boxes because we need to select units digit, tens digits and hundreds digit. Place value are very important in this type of sums. A 3-digit number has units digits, tens digits and hundreds digit. So students, if 0 is not any of the digits which is given, then you can start from either. You can start from left side also, you can start from right side also. So I am starting from left side. Now, when I am going to fill up the hundreds digit, I have 5 options. Out of this 5, any one can be there. So the hundreds place can be filled in how many ways? 5 ways. Yes or no? Correct. Out of 1, 2, 3, 4, 5, any of the 5 digits can be arranged as hundreds digit. Now after that, so the first event of filling hundreds place is done in 5 ways. After that, tens place. Now suppose 3 is arranged here. Now repetition of digit is allowed, so 3 can come in the tens place also. So again we have 5 options. So the tens place can be also filled in 5 ways. After that, units place, suppose 4 is arranged here. Now, after that, the units place also can be filled with any of the 5 digits. So the units place also can be filled in 5 ways. So, according to fundamental principle of counting, total ways in which all 3 digits can be arranged. Total ways of arranging 3 digits is equal to n into n into p, 5 into 5 into 5, which is 5, that is 125. So indirectly, 125 numbers of 3 digits can be formed using, students, the given digits 1, 2, 3, 4 and 5. So according to fundamental principle of counting, total ways of arranging 3 digits, or either I can write according to fundamental principle of counting, total 3 digit numbers formed are 125. So case 2, repetition of digits not allowed and I'm drawing 3 boxes. This is units place, this is tens place, this is hundreds place. Now be careful. Again, 0 is not a digit, so I have 2 options. Either start from left or start from right. Now I am starting from right. Now for the units place, I have 5 options. So the units place can be filled with any of the 5 digits. Now suppose 4 is arranged. So for tens place, 4 is not available. So we have only 4 ways. Either it can be occupied by 1, 2, 3 or 5. 4 is not allowed again because digits are not repeated. Suppose 1 is arranged. Then for you can say hundreds place, I have only 3 options. So the hundreds place can be filled in 3 ways. Therefore, according to fundamental principle of counting, total ways of arranging 3 digits or total 3 digits number form are 3 into 4 into 5, and that is nothing but 20 into 60. Then drastically reduced, more than half. So if repetition is allowed, you get different answer. And students, if repetition is not allowed, then also you get different answer. So very interesting, students. So if 0 is a digit, I cannot start from the left side because the 3-digit number never starts with 0. In case if it is written 0, 3, 5, then we consider it as only a 2-digit number. Now second, if the digits are repeated, then how many 3 digits even number can be formed using even 6 digits? Answer 2. Given 6 digits are 1, 2, 3, 4, 5, 6, and I want 3-digit even numbers, and repetition is allowed. So this is hundreds place, say this is tens place, and say this is units place. Hundreds place, tens place and units place. Now students, what is the basic characteristics of an even number? If a number is even, then its units place can be 0, 2, 4, 6 and 8. This is the basic characteristics of even number. Don't say last digit, you should say units place can be either of the digits 0, 2, 4, 6, 8. And of the given digits, the 3 even digits are 2, 4 and 6. So the units place can be only filled in 3 ways. So when it is a condition, this is called restricted sum. Restricted data means we have given some condition for the data, and that condition is that if number is even, then the unit space can be occupied by 0, 2, 4, 6 or 8 only. So the unit space according to our digits can be filled in only 3 ways. Now repetition is allowed. So for tens place I have 6 options, and for hundreds place also I have 6 options. Therefore total numbers of 3 digits, for total even numbers of 3-digit form according to fundamental principle of counting are 6, 6 and 3, and that is 36 into 3, and that is nothing but 108. So total 3-digit numbers form according to the given condition where the numbers are even and using the given digits 1 to 6, students are 108. Okay, the third sum. How many codes of 4 letters can be formed using the first 10 alphabets of English where you can say repetition is not allowed? Now first 10 English alphabets, students, according to the given data, we have first 10 English alphabets. And what are first 10 English alphabets? Then you can write given alphabets are A, B, C, D, E, F, G, H, I, J. Okay. And students, repetition is not allowed, and I want to form 4-digit codes. 4-digit codes. So I draw 4 boxes and say this is first digit, say this is second, this is third, and this is fourth. Now students, repetition is not allowed, so you cannot have code like A, B, D. Repetition of digits not permissible. So for the first digit I can start either or. I can start from left, I can start from right, I am starting from left. And definitely you can say we have 10 options for the first particular alphabet. The first alphabet can be, students, selected in 10 ways. Yes or not? Of course. Out of any 10 alphabet, one alphabet can be arranged. Now the second alphabet, suppose D is arranged. So for the second alphabet, we have only 9 options. Suppose B is arranged. For the third alphabet, say F is arranged. Now here 9. Now for the third, we have only 8 ways. And then here we have 7 ways. Of course. So total 4 alphabet codes or 4-digit codes formed according to fundamental principle of counting and Q. So 10, 9, 8, 7. So this is 90 into 56. So it is multiply 56 into 9. 9 6 are 54. So 504. So the number of codes are 5040. So this particular concept is very interesting. Students, if repetition was allowed, then the answer would be 10 into 10 into 10 into 10, because you could have the codes as A also, or A B also, where one alphabet is repeated twice or twice. So check, drastically it changes. If repetition is allowed, then students, the total codes which are formed is 10 into 10 into 10 into 10, and that will be 10,000. So check how this changes drastically. So if there was no instruction in the sum that whether repetition is allowed or not, then students, you have to do the sum in two particular cases. So this is like puzzle, very interesting. Using the digits 0 to 9, how many telephone numbers of 5 digits can be formed? And the condition is a number starts with 67 and digits are not repeated. Very interesting, students. Answer 4. Given digits are 0 to 9, and that is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. We are given 10 digits including 0. So number comprises of always digits 0 to 9. But number of digits are 10. Any digit number, isn't it? 15 digit number or 51 digit number. The number is always of digits 0 to 9. So 5 digit telephone number. So I am writing 5 digit T number starting with 67. For example, like this 67023. And number is always starting with 67. 5 digit telephone number starting with 67. A number always starts with 67 as per the given condition of the sum. I am not telling anything on my own. It is as per the given condition of sum. So for 5 digits, students, I have to draw 5 boxes. For 5 digits, we have to draw 5 boxes, and this is fixed. 1. Now the third digit can be 0. Of course, in a telephone number, one of the digit can be 0. Why not? In a telephone number, one of the digit can be definitely 0, students. Why not? So for the third digit, for the fourth digit, and for the fifth digit, what are the options? 6, 7 is already removed because it is told that digits are not repeated. What is the condition given and what is told, students? The digits are not repeated. That we have to carefully understand. So my third digit will have only 8 options, barring 6 and 7. Barring means barring, I mean to say excluding 6 and 7. Suppose 0 is occupied. So again now 0 is also removed. So the fourth digit has only 7 options and then 6 options. So according to fundamental principle of counting, 5 digit telephone numbers formed are n into n into p, and that is 8 into 7 into 6, so 56 into 6, so 356. Suppose repetition was not allowed and the number was not starting with 6, 7, then students, the first digit will have 9 options. Then again 9, including 0. You check, and then 8, and then 7, and then 6. If the number was not starting with 67, 0 cannot come in the first place. So the first digit will have 9 options. One of the 9 digits are already arranged. So 8, including 0, second digit will also have 9 options. Then 8, then 7, then 6. Then this answer would have been multiplied by 81. And if here only repetition was allowed, then the third, fourth, and fifth digit would have been selected in 10 ways each. And the numbers form would have been 1000. Check how the answer and the puzzle drastically students changes. This is very interesting. So this is the concept of this topic is widely used in gambling. But don't ask me how this is used in gambling. I am not supposed to teach you gambling. I am supposed to teach you the fundamental aspects of permutation and combination of these students. A balanced coin is tossed thrice, and each time the result is noted. How many possible outcomes are there? You have done this in probability students in 10th standard. Yes or no? Of course, in 9th standard also. Now, if a coin is tossed one time, the possible outcomes is set HT. H stands for head and T stands for tail. Now, again, if you toss a coin, then also out of head and T you have one outcome, and even if you toss it for the third time, out of head and tail, students, one of the outcomes definitely going to come. So if I am tossing a coin for 3 times, the total outcomes will be 2 into 2 into 2, and that is 2 cubed, and that is 8. This is simple Cartesian multiplication in probability when you do chapter 16. Students, I will explain this in detail, but at present, you only understand that this is Cartesian multiplication of set HT into HT into HT, which will be 2 into 2 into 2, that is 8. Suppose you are tossing a coin for 5 times, the possible outcomes will be 2 raised to 5, and that is 32. If you are tossing a coin for 8 times, the possible outcomes are 2 raised to 8. If you are tossing a coin for 100 times, the possible outcomes are 2 raised to 100. In general, if you are tossing a coin for n times, the possible outcomes are 2 to the power n. So this is very, very simple, students. You can easily understand and memorize this as a generalized concept also. Now, students, the last sum of exercise 7 on to 1. Now, students, the last sum of exercise 7 1 to 1. There are flags. There are 5 different color flags. Using this, how many signals of 2 flags can be found? Now, signals of flags are used in Olympics. Say, students, you are given 5 color flags: red, orange, blue, yellow, and white. These are 5 color flags. Now, these flag signals are used in Olympics where the countries participating, their flags are, you can say, arranged as signals. The countries participating, students, their flags are arranged as signals. So, in one signal, according to our condition, we have 2 flags. So, this is first flag, and say this is second flag. Now, for the first flag, I have 5 options. Suppose orange color flag is first. For the second flag, I have only 4 options. A flag cannot be repeated. So total number of flags formed are n into n, 5 into 4. Sorry, total number of signals formed according to fundamental principle of counting are n into n, 5 into 4. That is 20. If there were signals of 3 flags, then 5, 4, 3. 4 flags, then 5, 4, 3, 2, like that. So, this is a chapter which is a generalized chapter applied in day-to-day life. Let us revise once again the fundamental principle of counting in the lecture. Suppose an event can occur in n ways. After that, the second event can occur in n ways. Then students, the total number of ways in which both the events can occur in order are n into n. If there were 3 events, then suppose the first event can occur in n ways. After that, the second event can occur in n ways, and after that, the third event can occur in p ways. Then, according to fundamental principle of counting, all the 3 events in order can occur in n into p ways. And similarly, if there are 4 events, suppose the first, second, third, and fourth events in order can occur respectively in n, p, and q ways. Then, all the 4 events in order can occur in n into p into q ways. This is the fundamental principle of counting for 4 events. Students, the FPC, fundamental principle of counting, can be generalized for any number of events. It is neither restricted to 2, nor 4, nor 5, nor 10, nor 20. It can be generalized for any number of events which occur in sequence in order, but the order and the sequence of the events must be maintained. So students, here we complete our exercise 7.1 and the basics of fundamental principle of counting. We will continue with the further concepts of the chapter, students. In the next lecture, do this once twice, try to learn and write principle for 2 events, 3 events and 4 events also. Students, do not limit yourself to write the principle for only 2 events. You can write up to 3 events and 4 events also. Okay students, thank you. We conclude our lecture. The remaining students will do in the next lecture.